Hi, welcome to the Actuarial Data Scientist. Today we're going to be talking about order statistics. Feel free to pause if you need to read the problem. But the first thing we're going to talk about is actually bias. So bias is the difference between the expected value of the estimator you have with the actual true value. One thing that really annoys me about this problem is that it actually doesn't specify. I wish the problem used what's the absolute value of bias. I feel like the direction here, maybe I'm being dumb, but I feel like it's not that important. So instead of bias is the estimator's expected value minus the true value, you can think of it as you have your true value plus whatever your bias is equals your estimator. So in that sense, memorize it, know it. I personally wish this problem was just the absolute value of bias, but I could be being dumb here. Next, I just wanted to change notation. So I feel like traditional notation for bias variance trade-off for mean squared error, you typically see theta, and that's what I have listed here first. But in this problem, you have theta, which is not the thing you're trying to estimate, so I realize that can be confusing. So for that reason, I wrote it a second time here, and this is what we're going to use for the problem, which is mu hat and mu, because we're trying to estimate the true mean. And we're going to do so using theta. But so that's the first thing. We need to know what bias is and how to calculate it. The second thing is that the expected value of an order statistic drawn from a uniform 0, 1 is k over n plus 1. So this is something that when I took the exam, I just had this memorized, just mainly because of this problem. But we're going to get into how you could derive that on the fly if needed, but really this is just something I had memorized. I think the more important thing is to not be surprised by the notation within the problem, which is saying that you have, with order statistics, you have to use CDFs and 1 minus CDFs, right? Because you have values below the value that is your current order statistic that you're interested in and above, and then the PDF for the actual specific statistic of interest or the order statistic of interest. And then you also have this mess of factorials, which is a result of the different ordering of those points within those groups. But let's say, so the first thing in terms of going into the calculations, let's say you don't have this formula memorized. There is a way to kind of figure it out on the fly. So first off, it's simpler to use uniform 0, 1 instead of uniform 0 to theta. So we're going to start off with uniform 0, 1 and recognize that the PDF is just 1 in that case, and the CDF is going to be x. So using that and then plugging that into the formula we were actually given, we can then plug in the CDF and PDF, and we get this mess, which isn't too much better, but at this point we can actually recognize that this is just a beta distribution. So this is a beta distribution with alpha equal to k and beta equal to n minus k plus 1. So once we do that, we say, oh, it's just a beta distribution. You can go to your formula sheet and then plug and chug for what is the mean of a beta distribution. And that's how we end up getting this k over n plus 1. The one final step, so at this point, I recommend you just memorize that uniform. You're going to have these equal spacings for your expected order statistics. So, right, if you have a sample size 2, you would expect the one sample to be the median. If you have a sample size, if you had a sample size of 1. If you have a sample size of 2, you would expect them to occur at the 33rd percentile and the 67th percentile. Right, so that's all that is saying, and that's something worth just memorizing, I think. So what we can then do is take that and extrapolate to a more general form for uniform. So all you need to do is say those expectations of spacing over the width of the uniform we can just stretch that for the corresponding width and then shift it based off of its location. And that's what I have written down here. So still k over n plus 1, but then we multiply by the width. So that's going to be the maximum, subtract the minimum. And then after that, you add on the minimum value. And that just shifts it to where it needs to be for your corresponding uniform. So we do that with theta set equal to A and then 0 set equal to B, and that's how we end up with just k over n plus 1 times theta for our order statistic. We then know that we have a sample size of 4, and we're using the second order statistic, so we get 2 over 4 plus 1, or 2/5, times theta is the expected value for that order statistic. And this is actually our mu hat that I was talking about. So it's a function of theta, but the thing we're estimating is mu. So mu hat is equal to 2/5 theta. Next, mu is equal to theta over 2. So that's just going to be the midpoint of a uniform distribution is going to be the mean. So you can do the maximum, subtract the minimum, divided by 2 plus the minimum would get you there. But yeah, just ranging between 0 and theta, you just know it's going to be theta divided by 2. So then, yeah, finally, just knowing that bias is the expected value of mu hat, and then subtract mu. So we do that. 2/5 of theta subtract 1/2 of theta is just going to get you negative 0.1 of theta. And scrolling up, that's going to be C. So C is our final answer. As always, thanks for watching.